Welcome to UBG Bytes. Today we're tearing into some fresh intel from Google's online security blog, dropped July 30, 2024.
Yeah, and it's all about beefing up security for your Chrome cookies on Windows. They're using something called app-bound encryption. So our mission today, cut through all the tech jargon, really get to the core of what this means for keeping your data, locked down. Expect some surprising stuff and hopefully a clear picture without your head spinning. All right, let's unpack this first. What exactly is app-bound encryption? Like fundamentally, how is it supposed to protect our digital goodies?
Okay, yeah. So it hinges on this thing Google calls a privileged service. Think of it like a super secure bouncer running quietly on your system, a trusted part of
A
Windows.
bouncer. Okay, I like that.
Right. So when data gets encrypted, like a cookie, this service essentially encodes Chrome's unique identity into the encrypted data. It stamps it.
Ooh. Then, when anything tries to decrypt it, the service checks that identity stamp.
Hmm.
If it's not Chrome asking for its own cookie back,
Hmm.
well, Google says another app on the system tries to decrypt the same data, it will fail. Simple as that.
So it's like a digital ID check, but baked right into the encryption.
Exactly. At a really fundamental level.
That's pretty clever. So here's where it gets really interesting, right?
Mhm.
How does this app-bound encryption actually make life, well, a living hell for attackers compared to the old ways?
Yeah, this is the kicker.
Yeah.
Before, an attacker often just needed to, trick you into running some
It's a
malware.
phishing attack, yeah.
Right. But now, because this relies on that privileged service, they can't just do that. They have to gain system privileges or inject code directly into Chrome's processes.
Whoa, okay, that sounds much harder, or riskier.
Definitely riskier.
Hmm.
And honestly, legitimate software. It very rarely needs to pull that kind of, frankly, shady move.
Mhm.
So that makes their actions immediately more suspicious to antivirus software, way more likely to be detected. Plus, this isn't happening in a vacuum. It works alongside the event logs for cookie decryption.
Ah, so there's a record, too.
Yep, which creates even more noise, further increasing the cost and risk of detection to attackers. It's a proper pain in the ass for them now.
That is a huge shift. It's not just blocking, it's making them loud.
Okay, this raises a question, though. Are there specific places where this really shines? Like maybe big company environments? And are there any downsides? Any potential hiccups companies need to watch out for?
Absolutely. Yeah, for enterprise environments that do not grant their users the ability to run downloaded files as administrator, this is a big win. It's particularly helped.
Because the malware can't just ask for admin rights easily.
Exactly. It forces the malware into using those sketchier techniques such as injection, which, as we said, are more easily detected by endpoint agents. The security software companies run.
But, and this is a crucial but, app-bound encryption strongly binds the encryption key to the machine, like that specific machine.
Okay, so what does that mean practically?
It means it will not function correctly in environments where Chrome profiles roam between multiple machines.
Ah, like hot desking or virtual desktop setups where your profile follows you?
Precisely those scenarios. If the profile moves, the key binding breaks. So for those places, enterprises really need to follow current best practices for securing those roaming profiles anyway. Or they can configure this feature using the new application-bound encryption-enabled policy. Google built in a way to manage it.
Got it. So it's powerful, but you need to know about that roaming limitation. Okay, but, boots on the ground. How does an IT admin or even just a tech-savvy user know if this thing is actually working? Or more importantly, if something's gone wrong? What's the signal?
Yeah, good question. Chrome actually emits an event when a failed verification occurs.
Okay, like an error message.
More specific, it logs it. You need to look for Event ID 257 from Chrome's source in the application log in Windows Event Viewer.
Event ID 257.
Got it. That's your red flag. It means something other than Chrome tried and failed to decrypt a cookie.
Okay, stepping back a bit, if we connect this to the bigger picture, what's really fascinating here, what are the broader implications of this app-bound encryption for, like, the whole cat and mouse game of cybersecurity?
Well, fundamentally, it increases the cost of data theft to attackers. Massively.
Right, makes it not worth their while to
Or at least much harder. And
Yeah.
crucially, it makes their actions far noisier on the system. This helps defenders, the security teams, draw a clear line in the sand for what is acceptable behavior for other apps. It basically says legit apps don't need to inject code into Chrome to read cookies. If something is doing that, it's almost certainly bad.
Creates a clearer signal amidst all the noise.
Precisely. And Google's clear they're committed to continuing engaging with others in the security community on improving detections, and also strengthening operating system protections, such as stronger app isolation primitives.
App isolation primitives. Sounds technical. What's that boil down to?
Basically building better digital walls between applications running on your computer, making it harder for one compromised app to mess with or steal data from another, like your browser.
So reinforcing the whole system.
Yeah, exactly. Because the malware landscape, it never stops shifting, so, neither can the defenses.
Okay, so wrapping this up, what does this all really mean for you listening? Google's basically thrown down the gauntlet with this app-bound encryption. They're making it a real nightmare for bad actors trying to snatch your Chrome cookies on Windows.
Yeah, it's a significant step up.
And remember, it's not just about blocking. It's about forcing attackers into these louder, riskier moves that are just, well, easier to spot. It changes the game. So here's something to chew on. As defenders build these stronger walls, how long until the attackers figure out the next clever workaround? It always happens, right?
It's inevitable, sadly.
And what will that discovery mean for the next layer of defense we'll need just to keep you safe online? Makes you think.